Hello, welcome to the Cloud Multiplier. Today is our first episode, so we're going to have a bit more preamble than usual. We'll introduce everyone that is here with us today. But first, it is probably a good occasion to talk a little bit about this new live show presented by Red Hat. So we are going to be doing a show to talk about all things distributed cloud. So this is on-premises to edge, multi-cloud, multi-cluster, multi-tenant, multi-everything. It seems to be a theme in the industry ever since I started. It is my honor to be joined by Joydeep, and then my co-host, and then Caesar and Josh. We'll go around the room and introduce each other here in about a minute. I'll kick things off and say I am on the DevOps team for Red Hat Advanced Cluster Management. So I've been working at Red Hat for about 3 years now, and I've been on the same team with Joydeep and Josh for a good bit of that, so I'm honored to have them join. Based out of Raleigh-Durham, North Carolina, and most of my hobbies are kind of on the back wall here with board games. You want to kick us off, Joydeep? Tell us a bit about yourself.
Yeah, thanks, Gurney. Hey, I'm also, as Gurney said, with the Red Hat Advanced Cluster Management team. I deal mainly with observability and a little bit of how to scale the product, Red Hat Advanced Cluster Management, and deal with edgy things about, moving things to the edge. And I guess my passion is data. How to, all the data that we collect, how to make sense out of the data, how to use that data to make decisions. That's the, that's my mantra. That's the thing that keeps me alive. So having said that, Caesar, you want to take it over?
Sure. So I am Caesar Wong. I'm a developer in the Hypershift team. I've been working on OpenShift since version 3, and I've been doing all kinds of things, but mainly my focus has been on making consumers' life easier for OpenShift users, right? Like creating clusters, developing on clusters, and before working on Hypershift, I worked on Hive, which is also another way to another service to create clusters. And so I worked. I knew Gurney from there and Josh as well, because we interacted on Hive. So yeah, that's me.
Yeah, we made headaches for Caesar every day.
So true. My name's Josh Packer, and I am an architect for Red Hat Advanced Cluster Management. And I guess you could say, my being in life here at Red Hat is to take all of those clusters that Caesar is creating, both the original type, and we'll get into that, the standalone that came out of Hive, and the new that fall under the hosted control plane or Hypershift brand name that we're going to talk about today. But the idea of managing that fleet, and it can be a fleet of clusters that are your own, a fleet of clusters that are managed, a hybrid fleet of clusters, you name it, we're in that ballpark. And as Joydeep mentioned, and I point up because he's above me, at least in the picture I see in our little Brady Bunch window, but as well as at the edge. And so, I'm excited to be here. And Gurney and Joydeep, I want to thank you for bringing us here on your inaugural episode. We have the honor of being a part of it, which is great.
Yeah, thanks, guys. Thanks for joining. They gave a bit of a teaser for today's episode. Today is, of course, episode 1. Joydeep and myself will be joining you every week. Thank you to Joydeep for allowing me to bump him into co-hosting the show to get a bit more of experience on the show that isn't just my meager 3 years. But today we're going to be talking about a cool piece of technology called Hypershift. Something that I plan to break cause unbelievable issues with soon once Caesar lets me loose on it. But before we get into that, I have just blatantly stolen something from Andrew Sullivan of the Ask an OpenShift admin bunch. another show on Red Hat's live streaming platforms if anyone's interested. And we're gonna do top of mind topics. Thanks to him for allowing me to steal that name. And I've already talked to Joydeep a little bit, but I have not prepped Caesar or Josh, so we'll get true top of mind for them. So the big topic today, this first live show was supposed to occur when we were having Red Hat Summit, but now that we're 2 weeks out from Summit, we can talk about our favorite parts of Summit. So Joydeep, do you want to hit us first? I bet it's something observability based, right?
Yeah. So when we first spoke about this one, I had some totally different thing in mind. But since this is fluid, I'll tell you about Edge. So over the weekend, I was engrossed with trying to understand how the industrial edge works, right? Edge in telco, edge in finance, edge in manufacturing, they all look very different, right? So I was focusing on industrial edge because, as Gurney said, bringing some experience. Gurney is 3 years into Red Hat. I worked for 9 years in industrial automation, in industrial process control. So that's close to my heart. And that relates in some shape or form with how Kubernetes does things. So what I was thinking about is, in steel plants, you have these huge, gigantic machines, blast furnaces, rolling mills, and stuff like that, which are controlled with innumerable devices, right? So let's say you want to control pressure of a valve or temperature, right? You have a controller behind that. That controller is a closed loop controller, or it's sometimes called a PID controller. The main thing is it's given a reference point and it monitors the output. And depending on the error, it drives an action, right? And then there are supervisory systems that control the reference that's being set. Think about Kubernetes. Kubernetes has a desired state, has an actual state. If there's an error, it does something which is actually not proportional to that error. But in the PID control systems, which is going on for at least 60 years or so in industry, you do things based on error. So that was my realization, and that was, I kind of ruminated over it. So I'll still continue to ruminate, and maybe someday we'll talk about things here related to that.
Yeah. So what you're saying is we can now officially go into different spaces with less and more tolerance. I think is what you're saying for error. API error rates start to hit a little harder when they're controlling industrial equipment, I guess.
Yeah.
That's awesome. Let's see. We'll go around the corner. Josh, any highlights from Summit this year?
Once you said you were putting me on the spot, I was thinking, well, I can self-plug a little bit. So I did a summit. We did do a recorded Summit demo on GitOps, and it actually involves hosted control planes that we're going to talk about today and how you might do that as an infrastructure as code example. So I recommend you check it out. If you look up my name, you'll find it. I did it with Christian Hernandez, who runs the GitOps show. I think is it called the GitOps show?
GitOps Guide to the Galaxy.
GitOps Guide to the Galaxy, which is a show just like this that we live stream on a weekly basis. And so we talk about hosted control planes in there. I would otherwise say, it was, there were all kinds of sort of new pieces that came out. There was some good stuff on Edge too that I found interesting. I think, that seems to be the next space that we're moving towards, is we're running these clusters not just as clusters for your applications, but in these more purpose-built edge scenarios. It seems to be where the market is leaning and about to explode.
Yeah, that is awesome. So you're telling me I'm going to get the AWS bill later this month for
exactly
the live
for
stream
the demo.
Yeah. Awesome. DevOps team is here to handle that for you, Josh. Caesar, what did you catch? You haven't said mine yet. No one said my highlight yet.
Your highlight? No, I'd say watch Josh's demo. The hosted cluster.
Oh man,
I'll take that plug any day.
They're on top of it. Yeah, mine was definitely, no one said it, Microshift. That was definitely the highlight for me. I am all for running a Raspberry Pi with some Kubernetes there. might consider switching out K3s. I have a friend who runs K3s in his home, but has a lot more skilled up on the OpenShift side of things. So Microshift might be great for him. He runs Home Assistant. I don't know if anyone here runs Home Assistant, but really cool open source project for all things smart home. So awesome project. Okay, let's see. Since we got some highlights in, we got some cool industry things in. The last one that might mix into top of mind topics that I want to start doing, and I've talked to some fellow Red Hatters about this idea as well. I'm going to put Joydeep on the spot yet again, and I warned him. Any open source projects we should highlight today? I think we have one coming up in the next live stream, so you might be able to plug that one first. But I don't know if you have a favorite.
So one of the things I'm looking at is the Loki stuff,
Yep.
which is very fascinating, and having managed services in the past, having burnt fingers, getting woken up in the middle of the night and things like that. I have a particular take on how we should collect logs, not just collect all the logs and put it there, and that helps in root cause analysis, but when things are on fire, you need something more specific. So I'm taking a look at Loki with great deal of interest, and especially seeing, if we can collect critical events from remote places, and also what we call as metricized logs, get key messages out of logs, convert them to metrics and things like that. And Loki has a fantastic way to makes it very easy to correlate metrics and logs. So maybe we'll talk someday about that too. But that's very interesting to me.
I was going to say, I hope that'll be a future topic. Feel free. I'll drop the card up here. If anyone has any topic suggestions, we have an email address. I put that together yesterday and made sure it worked. So that's the due diligence here. We do have an contact email address. But I think, Joydeep, once we've had 1 or 2 weeks of having Caesar and other folks on to talk about how to get yourself into a big problem of having a couple thousand clusters, once you have 1,000 clusters, then you're really going to start caring about only getting the logs back you really need. So if anyone has any ideas, I did drop a link to Loki because that's an incredibly interesting project. Joy, I have to highlight my project was much less work related, the energy I'll probably bring to this show. I don't know if anyone here has toyed with really low level emulation, but I've very much enjoyed video game console emulation for a good bit of my life. Recently, I was reading the PCSX2, which is a PlayStation 2 emulator project, has gotten a facelift. So they actually got some UI folks in the community to make changes to their UI. So they're able to get a much improved experience. That's the sort of stuff that's awesome to see. Good highlight for Andrew Ronaldson, who made all the graphics for the show as well. He's a UX designer at Red Hat. Which is always good to see because they actually make an open source design system and language in Patternfly. It's incredible. So there's some reading. I'll send it to you, Joydeep. It'll be it's an interesting read. I've hopped in the community meetings. So.
And by the way, Gurney, the music that he used in the latter part of the video, that was indeed Smokey's Lounge by Stack Tribe.
Okay.
It's open source. I mean, it's not Smokey's Lounge by Track Tribe. Yep. That was.
We had to vet that. We did make sure we were allowed to use that. But that's awesome. And he hit I told him free reign, and he hit jazz, which was perfect for us, Jody.
Exactly.
Okay, well, without further ado, I've made him wait long enough. I know Josh and Caesar are here with some infrastructure ready to show us. So let me give the quick primer, the few lines that I did very little research on Hypershift, so I can ask all the dumb questions. So I guess my first question is, what is Hypershift? That's the best way I can ask it. What is it? So who's going to share first? I think it's you, Josh.
Sure, I'll take the share, but I think we're definitely going to tag team on this a little bit as we go. And
Yeah.
the first thing I'll say, like I say in all our other meetings, since Gurney works with me all the time, is there are no dumb questions. Any question you ask, there's definitely at least one other person thinking the exact same thing. So let's start from the top. What is Hypershift? And so actually, Caesar just mentioned this, and I lose track of this fact, but Hypershift itself is not a product that is coming out of Red Hat or elsewhere. It is literally a project that we're working on within the OpenShift space that brings us this separation of worker or workload and control plane. And so today, what you see up on the screen, we've got one of the forms of OpenShift that you can get today. And so there's standalone OpenShift. You'll hear us sort of refer to that term versus hosted OpenShift and hosted control planes. So you have standalone OpenShift that comes in a number of flavors. One of them is the multi-nodes, where you've got the control plane nodes and the worker nodes. Then you've got the one we've got up here, which is the more compact sized one, where you've got your control plane nodes and your worker nodes combined together. So it starts out as maybe a 3-node. We've got in the bare metal space, which has been released, is the single node OpenShift, or also referred to as Snow, where you've got, again, your control plane and your worker workload running on the same piece. And so Hypershift is a project that sort of takes this the next step. But number one, it's to solve a number of things as well. Caesar, why don't you?
Yeah. So basically, people came to us with problems, right? The current OpenShift solves a lot of problems, and it's great. But then there's a few issues that people came up with. Like it takes longer than I would like for the cluster to come up, right? A lot of the compute that I'm dedicating to the cluster is being taken up by infrastructure and the control planes. I have a large cluster, but I mean a large machine, and I want to partition it into multiple clusters. But the current OpenShift requires separate machines. I want to have workloads in the cloud, but I want to manage it locally, or vice versa. I want my workloads to be inside my VPC, but then have them managed elsewhere, right? I want more space for my cluster. The workloads, the control plane is taking too much, right? And so to answer these, we started working on Hypershift. Hypershift is the concept of moving the control plane into another cluster, right? What we would call the management cluster, and then free up the workers to only run workloads. And so when you look at this graphic where you see the control plane and workloads in a standalone cluster, you start out with 3 and 3, right? Like it's half and half control plane and workloads. With a Hypershift cluster, you're only using a little bit, and that's on the management cluster. And then most of the space is given to workloads. The actual workers run your workloads. And so the control plane is just a set of pods in a regular OpenShift cluster, right? And then the workers get initialized, they connect to those pods and become part of that cluster. And in this model, this management cluster can host many control planes, right? So you can have hundreds of control planes in a single management cluster, which saves you on separate compute for masters. It makes management more central in the sense that you have a management cluster that has all the pieces that are needed for the control plane. And then the workers are more free to run just the workloads.
Yeah, and I'm guessing I'm guessing it's probably namespace bounded. So you have namespaces as your boxes for all of these control planes of clusters running as.
Yes.
Okay.
Yeah. So every control plane is located in a single namespace. All the pods that belong to that control plane are going to one namespace of the management cluster.
So debugging a bad kubelet or a bad etcd replicate is as easy as looking at a pod on a cluster rather than SSHing into my node that is on AWS that's angry.
Correct. Yes.
So goodness, that opens a lot of possibilities for just deleting bad replicates and waiting for them to come back, right? Might not be a good idea.
And to piggyback on that, let's take, for instance, the physically distributed yellow data plane. So that's a set of nodes. That's a set of nodes that's running, like Gurney said, in Amazon. And the control plane, that is the Kube API server of that, is running in a regular namespace. The Kube API server, etcd, etc., running in a regular namespace on the management cluster, right?
Correct. Yes.
Fantastic. So,
wow.
Go ahead.
I was going to say, so, and the other question that always pops to mind, we have like so I know HA, usually you have 3 node, then single node let you have a single node. I assume that the Hypershift control plane is HA 3 replicate usual deployment on the management cluster.
You can run it either way. So you can run it if we're looking for compact and small, and you feel confident that if the node that parts of that control plane we're running on were to go down, that they would be able to come up, and you had enough resource to back those on the additional nodes, then you could run that way. And there, the catch is obviously the RTO. There is a possibility of a short outage if, say, the API servers disappeared on that. But you can also run it in HA mode. We call it DR mode, where it's done in triplicate as well. And so you have 3 of each, just like you would on a normal physical set of control planes, control plane nodes, that is. And so we actually did have a question, so maybe we'll jump in with that one. And so
I was about to hop onto that. Let's see. I have a show button. Let's see. There we go. We can actually show it on screen.
That's
We're asking about virtual worker nodes. So on bare metal, they don't have to bother with ignition configs. I assume for provisioning the actual worker nodes, the physical worker nodes.
So, yeah, Caesar, you want to talk a little bit about?
No, go ahead.
No, I was just going to start to talk about when I see this and we talk about sort of being able to put something together on bare metal as an example, and not have physical other servers used as worker nodes. It gets into the KubeVirt space, and I guess I don't think we have a slide that specifically calls out the different platforms that are available, which means we definitely should add one. But you've got today at least support for that's in development preview and tech preview, depending on which platform it is. We've got AWS, we've got Azure support, we've got KubeVirt support, which would allow you to create virtual worker nodes on your single, so all contained in a single OpenShift cluster. You can have the control plane and the worker node, the virtual worker nodes running. And the last one is escaping me now, and I don't know why. Agent, that's right, for bare metal. So you can have the control plane running on bare metal, and then you can have individual servers become nodes for that in a virtual control plane space.
Okay.
Yeah.
So KubeVirt's your answer for those virtual worker nodes, then probably. And then go ahead, Caesar.
No, I was going to say, so far that is, the way we allow you to partition these large machines. The question was about I don't know if it's virtual kubelets, which are different than just virtual machines, right? And that's an interesting thing, but we have not looked into that, right? Like having one single machine running everyone's workloads and then running the virtual kubelets to represent nodes on different clusters. That's an interesting idea. It's just we haven't explored it yet.
So Caesar, what you're saying is GCP support, then maybe vSphere, then we'll look at letting you nest more. I mean, I'm going to try to go to KubeVirt and put a cluster inside of a cluster inside of a cluster, because I think if you can get 3 layers deep, you can kind of keep going from there, Inception style.
Yeah.
What is the saying? What you say on a live stream is now in stone forever.
Oh no, these are not quotes. Hey, if you really want to, I dropped a link to the Hypershift community repo in chat, so that's another great place to follow up with Caesar and the team.
Absolutely.
Yeah. I think you guys, I have a list of questions. So spoilers, a little bit of backroom talk to everyone who's live here. I put together a list of dumb questions to ask. And then they came and said, well, we'd love to talk about this. And they happened to answer all of the questions in the correct order, which was shocking. But my first questions were, what is it? How does it work? I'm going to ask a lot of questions and who is it for? My next question, though, Caesar, Josh, where did the idea arise? Is this going to be practically used anywhere inside of Red Hat, inside of other enterprises? Is there like a parent project that inspired this?
Yes. So definitely hosted control planes is not new, right? There's a lot of other companies that are offering hosted control planes. So all the, GKE, all the XKS providers do some form of hosted control plane. SAP came out with Gartner, which has been a project for a long time. But we hadn't tackled this in OpenShift until IBM came to us. They had been offering OpenShift 3 as a hosted control plane way before we knew. We had no idea IBM was doing this, but they were running and actually offering to customers managed control planes for OpenShift 3. Well, OpenShift 3 was, fairly straightforward. It had mono binary that ran everything. It ran the Cube API server, controller manager, scheduler. It was fairly simple to run this way. Once we put out OpenShift 4, then things got interesting because everything was controlled by operators. And so there were operators operating on each piece of the control plane, and there was a ton of moving parts. And then IBM was like, we need Red Hat's help. We can't do this on our own. Right. So they came to us and they said, we the only way that it makes sense for us to offer OpenShift is on this hosted control plane model, and we can't offer it, standalone. So how can we work together to make OpenShift something that we can offer? And so we started a joint project, and actually you can still see it in the OpenShift org, is the IBM Rocks toolkit. And basically, it was a collaboration with IBM to get to a point where we could run control planes in a hosted way, right? And if you look at the Rocks toolkit, it's basically a CLI that renders a whole bunch of manifests for you, and basically would render all of the pods and deployments and everything that were required to create a control plane. IBM put the other piece around that, which was a lot of Ansible code to create machines, to deploy these pods on management clusters, and set up networking, set up certs, and all kinds of good stuff. So that's how we started. We actually had the problem on the Red Hat side that we did not have access to IBM's internal environment. And so for us to be able to develop and test our portion of that toolkit, we needed a way to run it on something like AWS or on bare metal. And so we started, I had a very small installer that would take the output of the CLI and would actually run OpenShift on AWS. And
wow.
yeah, I mean, and it was only for the pure necessity of debugging,
dev
right?
test.
And testing ourselves. But we showed it around, and actually people thought, like, hey, why are we not running this, right? Like, why can't we run OpenShift like this? And so the whole Hypershift project got started into like converting that into something that would actually make sense as an OpenShift form factor.
Wow. And that's how long has this been running? About a year? Or I saw the first rumblings of it, I think about a year ago, right?
Probably a little bit more than that.
Okay.
But the work with IBM started in version 4.3.
Wow.
I think was the very first version of OpenShift. And so it's been a while. Probably at least 3 years that we've been looking at this.
That's incredible. We have a very relevant question. We have some awesome questions today about the resource requirements for a 3-master hosted control plane. It should be less than regular 3-master nodes. Put Josh on the spot here. I think especially might know this. We've been sizing our own internal deployment as I prepare to set my set of 120 developers loose on this to break it and cause some headaches. Josh, what are we looking like for the utilization?
Well, I was going to say I didn't think we'd published anything quite yet, so I don't know what I'm allowed to say or I'm going to say on this. Just that when you virtualize the control plane, obviously what it allows us to do is bin pack the pods more so than you would otherwise on a controller that would be sitting, say empty. And so, I mean, the numbers we get are starting to bring us in range with what other cloud providers offer for virtualized control planes, at least from a costing perspective of what it costs to host it. And maybe I'll use that to semi-segue off of the neat part about this as well is that through MCE and ACM, MCE being multi-cluster engine, which you find inside of ACM, which is advanced cluster management, the product is this is the first time we put that in the user's hands. So the administrators in your data center are able to take advantage of this technology starting with ACM 2.5 to be able to host your own control planes. Now you can choose to do that in a cloud provider, but also do it on premise in your data center as well and take advantage of that savings and that packing of pods where you otherwise may have a control plane that was sitting 50% unutilized. And especially in the on-prem circumstances where you're buying servers of a specific size, and so if you weren't utilizing those, they aren't going to be filled up. Whereas now with the virtual control planes, you have a bit more leeway of as you build up, making sure that you're fully utilizing it, just like you do in any virtualization technology. And then I saw a whole bunch of questions pop in.
Yeah, we had a few more questions. First one I'm going to say, since Josh is not allowed to talk about our sizings yet, little birdie tells me that we'll be able to talk about that here in a few weeks, hopefully. So I asked, I'll toss this card up. Send an email to cloudmultiplier@redhat.com. We'll loop in Josh. And once we have official figures, then we can send you the announcement docs and any information that might give some sizing on that. So I didn't know that. So you caught me off guard. I'd love to put Josh on the spot.
Well, or I'd say it and it would come back to haunt me at some point.
Yes, exactly.
Or as I said before, so it'd be, but like in this YouTube stream, you told me it was only going to cost me.
Yeah. Well, go ahead.
No, what I was going to say, it is definitely less than standalone machines.
Exactly.
It is significantly less.
Yeah, awesome. The other question sounds very interesting to me because I want to do terrible things with clusters and clusters and clusters here. Someone asked about OVN-kubernetes, container CNI, and Hypershift. So has anyone played around with this?
Yes. So starting the most recent version of Hypershift runs OVN-kubernetes as its SDN. We started with OpenShift SDN, but recently we have switched to OVN-kubernetes, and the folks in the networking team did some awesome magic to make it work. And yeah, if you get the latest builds, you'll get OVN-kubernetes.
Awesome. And that's the Hypershift project, should be linked in chat as well. So the next question, Caesar, I think segues into my next question. So man, chat is on top of things today. Andrew was asking how compute nodes are provisioned off of the parent cluster. We already talked about, can I have a virtual worker node? What does the lifecycle mechanism look like for a worker node after you have that control plane running in a containerized fashion on your management cluster?
Sure. So internally, what we're using is the cluster API project, mostly as an implementation detail. So what happens when a new cluster is created, you have normally...
Okay, wait, I'm going to interject for just a second because I thought this was the perfect moment for a segue into a demo of this live.
Yes.
There we
Assuming the demo gods are smiling on us.
Okay. So let me actually show you.
Okay, Caesar, we'll put you live here. There we
Okay.
go. This is Caesar's screen. So
yeah, so this is a cluster that I'm connecting to through K9s. It's basically showing two different CRDs, right? Which is the main API of Hypershift. One is hosted clusters, which represents a cluster and the control plane associated with it. And then another one called node pools, which is the machines that you're going to associate with that hosted cluster. There is a one-to-many relationship between hosted cluster and node pools. You can have many node pools per hosted cluster. Mostly equivalent to this in current OpenShift is this would be a machine set, but with a lot more stuff than our machine sets have currently. So these are the things that you interact with. And if I go and create a new cluster, I will go and create. This might create. There we go. I create a cluster in AWS. And so what you'll see here eventually is that I'll get a new hosted cluster, a new node pool. First, it creates some infrastructure on AWS to host them. And then here you see them, right? They show up. Now, what happens with this is that as soon as that hosted cluster is created, pods representing the control plane start getting deployed. And one of those pods is the cluster API manager and the cluster API provider. Those, depending on which provider your hosted cluster is creating, you will get a different provider pod, right? In this case, it's AWS. So my provider is going to provision AWS machines. And so if I look at machine deployment, let's see, sorry, machines. You'll see that I have 3 machines created for this hosted cluster that I just got started creating. And those correspond to AWS machines, which are the things that the provider works with, right? The provider will start looking at these, will start creating new instances for them. And then when the instance is ready, it will say, I'm ready here. And so this is the thing that will create new machines for us. When you look at the at what that node pool looks like, let's go look at the node pools. So we'll look at this. See if I can manage to get this pane resized. Okay. All right, so the YAML for the node pool has a good bit of stuff. It says what the platform is for the node pool. So in this case, it's AWS. And it has AWS specific stuff like what kind of instance, the root volume, the security groups that it needs to belong to, subnet, where the machine is going to be placed. The release image for the Arcos OS image that will be laid down on the machines, and also, that controls the kubelet version and how many replicas I want. There's also other things that I can specify about my node pool. So for example, I can say that I want it to be auto-repaired to true, and that results in machine health checks getting created for it. I can also say how I want my node pool to roll out upgrades or changes to the configuration. We have 2 strategies for upgrades. We have replace, which basically throws away the machine, creates a new machine. And we also have in place, which was recently added, which basically just applies a new ignition payload to the machine in place. Let's go back and look at our machines. Okay, so now the machines have been deployed. They say they're running. They have an actual instance ID. If I look at machines, they are attached to my cluster. Eventually, they will get a node name here, which means that they have been added to the cluster. If I look at my pods, you'll see that I still have some pods starting up here. I have etcd, I have Kube API Server, Kube Controller Manager, and yeah, they're still initializing. Eventually, they'll come up, and my control plane will be up and ready. So if I look at one that I had already running, let's see.
I was about to joke this is the part of the demo where we talk for 2 minutes while the cluster comes online.
Yes. So this is another one that I had running before we came on, and you can see all the pods that are running, the etcd and the cluster API, Kube API server, Kube controller manager, Kube scheduler. They're just simple pods, right? If I create an HA cluster, you'll have 3 replicas of each. They have zone and T-affinity, so each one will be deployed in a separate zone of your management cluster. And yeah, they'll you just get a lot more here. Let me see what else. So let me get back to here. It's still going. Okay.
And Caesar, did we show the API, the Hypershift cluster API, where we are setting the?
Yep. So let me show you that. So this is the node, right?
Yep.
If you go to the hosted cluster, we can show that. And basically, this is the YAML for the hosted cluster. It has the most similar thing to this on the standalone OpenShift side is the install config, right? It has information about networking, about the DNS, how is etcd persistence managed. You can set for example, the storage class for your etcd storage. Mm-hmm. Networking CIDRs and so on. And then platform-specific settings. In this case, it's AWS as well. So we have a VPC. We have credentials for different parts of the cluster. So one thing that is worth mentioning here is that as a design principle, we don't want to store your tokens or your passwords or anything that could, sort of compromise your account. So the end user, basically what they create is roles, and we use STS to use those roles and do the limited operations that those roles allow. So if you look here for the different pieces or different roles that are passed in to us, we have an OpenShift ingress, and basically the role says that this is a role that you created and you allowed the management cluster to use via an OIDC provider, right? So that you're not, this is all the creds that you're giving us, and we're in the management cluster, we're not storing any of your creds. And so, yeah, that's something we wanted to get right in Hypershift.
That's a very big point, right? Since this is a single control plane of all the fleet of clusters that are running in probably your enterprise, in whatever cloud. This plane isn't storing any credentials, whatever you're giving. And I guess Caesar, Josh, you guys will say probably this the access to this control plane doesn't need to be open either, right?
Correct. Yeah.
Right.
So the Kube API server endpoint of the management cluster does not need to be public, right, at all, right? And so it is much harder to hack. Something else that we do as a default is encrypt etcd secrets at rest. So by default, we will use AES CDC encryption, just like standalone OpenShift. But we also support AWS KMS provider for encryption, and so we never have to even know what your keys are, right? Like even though we're storing your secrets on the management disk, we can't read them from the disk because you own your keys, and all you tell us is the ARN to your keys, and we can't decrypt it.
Awesome. Caesar, we had a related question that's probably good to slot in here while you're showing us the install config equivalent. And there's already been some chat, but I wanted to make sure we addressed it. How will infra nodes work? I see this in two ways. One, can I have a Hypershift cluster with infra nodes? And then two, can I host Hypershift cluster control planes on infra nodes? I don't know what we have to say about that, but I suspect that infra nodes are just differently labeled nodes.
Correct. Yes. So by default, we don't force you to have infra nodes. But basically, you can create a separate node pool that you label infra, right? And update the different operators that run inside the guest cluster to be scheduled onto those dedicated infra nodes from your infra node pool. So things like the image registry, ingress, the monitoring stack, you could move to those infra nodes. The other thing that we're looking at is potentially making those some of these things that get deployed by default optional, right? You may not care for a monitoring stack. You should not have that running on your workers if you don't want one, right? Or you may not need an image registry, right? Because all your workloads you already have your own registry, right? So we're thinking of making those optional. It's not there yet, but that's something that's going to eventually come.
So there's a couple more questions. So the vCPU licensing side, if you want to send the link, and Gurney will put the email back in there, and we'll get a PM to respond to that. We were supposed to have a PM with us today, but they weren't able to make it, so you got just the tech crowd.
Yeah, I was just typing that up to say
we'd be happy to get you info on how the licensing side of it works with the vCPUs in the Hypershift space. And then there was one about install. So it was asked below, and I think Gurney had written it in the chat, but so the delivery mechanism to get access to hosted control planes is through ACM and MCE. And so MCE is an operator that at a very basic level is available for any install of OpenShift and with any OpenShift license. So if you have a deployed OpenShift, you can add the MCE operator and either turn that cluster into a Hypershift management cluster or hosting cluster for control planes, or you can use it to create other OpenShift clusters and use those as hosting clusters as well, or management clusters. We use those terms interchangeably. Management cluster is a hosting cluster for our control planes.
Yeah, we actually have have someone ask the next question on my list as well, which is, what does the networking look like? How do the nodes connect to the management cluster? I'll extend that question a bit. I'm going to steal the question a bit and say, is there a benefit to have your control plane management cluster in the same data center, cloud, region, et cetera, that you have your worker nodes? Are we sensitive to latency?
Yes. So normally, I mean, at least in the same region, right? So it depends. For example, in AWS, we support private guest clusters. And the way that the private guest clusters communicate with the control plane is via private link. So no network goes through the cloud. It just goes internally within Amazon. And if you are using that, your regions and zones need to match with the management cluster, right? Like that. It's a limitation of AWS. Both management cluster and guest cluster need to have the same regions for private link to work. There's more flexibility if you're not doing that, if you're not using private clusters, where I would say we would recommend running within the same region. And if you're going to have multiple management clusters, at least have one per region where you're going to run your workloads. Yeah, that would be what I would recommend. So networking. One of some of the more interesting things about Hypershift is the networking piece, because it is a little bit different than standalone OCP. So communication between the workers and the control plane is fairly straightforward. The control plane is exposed via a load balancer. That load balancer can be public in the internet, or it can be a private load balancer in the case of private link. The communication from control plane from Kube API server into the kubelet for things like logs, exec, and so on happens through the Kubernetes API server proxy or connectivity. Initially, we had a VPN set up to do that. We were using OpenVPN, but connectivity seems like a better solution for that. It's an application layer tunnel. So basically the way it works is your worker dials into the control plane because it can access the control plane. And then through the tunnel established by that worker, the control plane talks back to the worker. And yeah, that's how that communication is set up. Let me see. What else?
I was going to say, and spoiler, although not officially supported, so you can, for example, have a control plane running on AWS. And to answer one of the questions, it's AMIs under the covers. So the control plane is pods. The workers in AWS would be AMIs, but you can have the control plane in AWS while the worker nodes are in Azure, as an example. And at least it'll connect up, and for basic workloads it works. But as Caesar was pointing out, like it depending on what you're doing, I think it's you need to be cognizant of the fact that you're literally traveling across the internet. And I suspect that, and again, we don't have PMs here, so we can talk about all the possibility, but I suspect the official matrix will be a little different. But just to give you an idea of sort of the cross connecting that can be done, it's going to be quite interesting over the next few months as we start to pull these pieces together.
Josh, Caesar, you only need to say this is the Hypershift project speaking, not the product.
Yes.
We're engineers. We're just going to tell you what we've hacked to get working. There's Caesar. I just have to put this on screen because they've had a taste of it, and they're wondering when they can have VMware and OpenStack. I think the best answer for this that I'll try to ad lib is the Hypershift project is an open source project, and they are working as quickly as they can to get there, but it's also a great place to collaborate. So if there's something like that you're interested in, I myself am going to go read the code base. Anything from you, Caesar?
No, definitely. I can't give the PM answer, so I just say come talk to us. Come
Yes,
collaborate.
definitely in the community. It's one of those things. The more upvotes, the more issues we see for it, the higher we're able to. It helps us push these things higher up the stack.
Yeah, awesome. Let's see, Joydeep. I know you had a question or two. We're hitting close. We might run over a bit, but did we have any questions from Joydeep, the true expert?
No, I think Caesar already answered that. While talking about the security stuff, that was paramount in my mind. How can we make this secure? And Caesar explained that.
So maybe I'll add the two. I'll come back to how do you get this again. So you start with an OpenShift cluster. If you go to Operator Hub and you look for Multi-Cluster Engine or Red Hat Advanced Cluster Management and install those. But from a licensing perspective, Multi-Cluster Engine is available to you with just your OCP license. You activate that, which is about a 2-minute procedure for the operator to deploy. You add an add-on, which will activate the Hypershift operator, which is what's doing a bunch of the heavy lifting, initializing this stuff that we just saw demonstrated by Caesar under the covers. That will initiate it on that cluster itself and make it a management cluster. Or you can create other clusters or import other clusters with ACM or MCE and make those into management clusters as well. At which point you can start to create your fleet. There's that word of hosted clusters and hosted control planes.
Awesome. And I dropped the project link in there. I apparently pasted the link twice in a row, which is just skill from me. So y'all can figure that out in live chat. It's my bad. And let's see. Before we close out, we'll probably wrap it up if no one had anything else. And then I have one last thing to pop up on screen. We can laugh about it, give a non-committal answer, and then disappear before we're back. Every second and fourth Tuesday. I know that causes headaches. It would have been worse doing every other Tuesday because there are like 2 fifth Tuesdays every year. So we'll be here 1 p.m. Eastern every second and fourth Tuesday. Now to read us out, we have my favorite comment from the day that we can chuckle about and make a non-committal answer about, which is the intention for the Hypershift project to work with the managed solutions like ARO?
So I'll say I saw a bit of a nod there from Caesar, so we'll blame him. But
I can't say anything about this one.
I think the statement we can make here, though, is that we talked about how this is the underpinnings for what IBM is doing in their managed offerings, and so it's easy to understand and extrapolate how this becomes a part of Red Hat managed offerings as well. And Red Hat managed offerings include, but are not limited to, OSD, ARO, and ROSA spaces.
Josh, that was even more of an answer than I expected we would give here. So I think chat will be incredibly happy. PM might yell us a little bit. So that was
awesome. My commitment without a commitment.
Yeah, there you go. Well, thanks again for Caesar and Josh for joining us. Thanks for co-hosting with me as always, Joydeep. And we'll see everyone in 2 weeks. Feel free to send us an email if you have anything at our show contact. Otherwise, catch you in 2 weeks. We don't have an outro yet, so I'll have one by then. See y'all.
See ya.
Thanks for having us.
Thank you.